Greetings. My name is Dick Hutchinson. My career was with the U.S. Army, working on chemical and biological defense at Aberdeen Proving Ground in Maryland. I want to present an overview of our wicked problem approach for solving complex problems such as global warming. Wicked problems have a mix of technical, economic, and social political factors that are snarled together much like a Gordian knot. People very often deal with such problems by first ignoring them or leaving them for others to deal with in the future, or by treating just the symptoms. As a result, these too hard to do problems are often left unresolved. But global warming is a problem, a wicked problem, that we must resolve. We must solve it. To do so, however, requires a non-business as usual wicked problem approach. I want to give you an overview of this approach by sharing with you our actual experiences in discovering it, in using it, and our lessons learned along the way. I believe this will help you to understand where did this come from and how does it actually work. Let me pull up our slides. Let's begin with our first example of using when we actually discovered this wicked problem approach. And our first use was on the chemical weapons treaty verification program conducted from 1990 through 95. Congress mandated DoD to do this work in support of US negotiators in Geneva who were negotiating this international United Nations treaty. Since the treaty would require the US to destroy its new modernized chemical weapons, which cost billions of dollars, Congress wanted to be assured that the treaty would have effective verification measures. The draft treaty required verification of 7 types of facilities and operations. We viewed them as components of the verification problem and called them verification scenarios. The first was a single small-scale facility that each nation could have to make small quantities of chemical agents to test against their chemical weapons defense equipment. Schedule 2 chemicals and facilities included toxic industrial chemicals such as phosgene that could be or were used as chemical warfare agents. Schedule 3 chemicals and facilities included industrial chemicals that could be converted to chemical warfare agents. Scenarios 4, 5, and 6 addressed military chemical weapons storage, production, and destruction facilities. Scenario 7 allowed for anywhere, anytime challenge inspections. Inspection measures for each scenario had to detect and deter cheating, have lowest practical costs since the US would pay much of the UN inspection cost, and each measure must also have an acceptable level of intrusiveness to the US since we too would be inspected. We started with a blank sheet of paper and developed a program strategy. Of course, to sell our program, we had to boldly say, sure, we know how to do this. Our strategy included forming a multidisciplinary team for each of the 7 scenarios, using a model site for each scenario to present the verification problem in physical form, conducting 3 field tests for each model site. The first was a baseline survey used to identify and evaluate verification options for effectiveness, cost, and intrusiveness, and then balance these factors for best practical measures. Second, an equipment field test was conducted to test equipment and procedures resulting from the baseline survey. Third, a full-up demonstration of the recommended verification system for each scenario was performed to validate our results. Furthermore, we needed to integrate across all scenarios to arrive at comparable levels of effectiveness, cost, and intrusiveness. We used this preliminary problem diagram to explain and sell our program. We show the series of field tests that are staggered in time. We later decided to allow all teams to begin their work simultaneously. There was no reason to hold up. We also eliminated the third series of subsystem tests as we found they would be unnecessary. Program participants included 272 engineers, scientists, and others from 21 organizations, including 7 national laboratories. The model sites are shown in blue. Most are Army sites involving chemical weapons. Oak Ridge National Lab was used to test challenge inspections, and DuPont Chambers work was used for Schedule 2 and 3 industrial chemicals. Members of the on-site inspection agency who participate in inspections of Soviet nuclear weapons also participated. We set up a technical advisory committee of senior people, including a retired major general, to follow the work and provide independent feedback and advice. Here we show our program results. These included inspection handbooks detailing the verification activities, equipment, and personnel for each of the 7 verification scenarios. Reports were prepared for each field test for each scenario and stood behind these final reports. During their work, the teams found verification language in the draft treaty that needed to be changed and prepared issue papers presenting and explaining their suggestions. A training program for inspectors was also prepared to assist the United Nations in training its future inspectors. The program was continued 2 more years to allow Lawrence Livermore National Lab to develop a portable laboratory for on-site chemical analysis of chemical agents, and for Sandia National Lab to develop an agent sample container for transport on commercial airlines. Well, how were our results used? Program results were accepted by NATO and endorsed to their delegations. Of our issue papers, 20 of 24 were included in the final treaty language. A DoD representative at the Geneva negotiations stated, "Knowing what is and is not possible was extremely helpful during negotiations." Program results were provided to the UN Technical Secretariat for use in inspection protocols. I assumed that they were used as there was no comparable program by any other nation. Well, what were our lessons learned? Here's what worked well. Dividing the problem into components, the 7 scenarios, having a problem diagram to describe the problem and program, using multidisciplinary teams for each of the verification scenarios, educating participants on the problem using model sites. We found it was okay to work on all components simultaneously. We can evaluate options on effectiveness, cost, and intrusiveness and balance these factors. We must iterate the process as learning increases. We use the 3 field tests as steps in this learning. The individual team results for each scenario could be integrated into a verification system. We knew that we had a successful program, but we had no idea that our strategy had application to other very complex problems. Well, after completing the chemical weapons verification program, we faced another complex problem involving biological terrorism. This program, titled Biological Warfare Improved Response Program, was also mandated by Congress and required DoD to train U.S. first responders and test and improve responses to biological and chemical weapons emergencies. The program was conducted in years 1998-99. Congress was concerned about U.S. preparedness to an attack like the cult Aum Shinrikyo release of nerve agent in Japanese subways. As we diagrammed this problem, we had an eureka moment. We realized that we could adapt our approach from the chemical weapons verification program to this problem. We again formed multidisciplinary teams of fire, police, hazmat, emergency medical, and emergency management personnel. We used realistic BW attack scenarios against civilians ranging from small, medium, large to very large scales, and also included an agriculture target since the U.S. Department of Agriculture was concerned about a biological attack on our food supply. We educated participants on biological weapons and their use so that they had a realistic understanding of the problem. We conducted week-long workshops for each of the 5 biological weapons attack scenarios. Participants evaluated response measures for effectiveness, cost, and social political acceptability. They integrated the workshop teams for effective practical response system. Program participants included 88 emergency responders and technical and medical experts from 39 agencies. New York was recruited as the model city with the New York City Mayor's Office of Emergency Management as the focal point. They provided experts from New York Fire, Police, Hazmat, Emergency Medical, and Emergency Management who were vital to the program. We also had emergency responders from Colorado, Delaware, Florida, Kansas, Maryland, New Jersey, New York State, Texas, and Washington. Many federal agencies participated because of their various roles in responding to national emergencies. Program results included a biological weapons response template and an integrated modular emergency medical system. These response measures were included in the biological weapons responder training program. After the program ended, Dr. Robert Gougelet from Dartmouth College and Medical Center learned of our work and obtained a CDC grant to generalize the biological weapons response template into a regional response system for all types of catastrophic emergencies. With his help, this system was identified in a number of states and cities. Some cities used the medical modules in their response to COVID. We learned some key lessons from this program. In particular, we demonstrated that the treaty verification program approach worked successfully here. We did experience some tense moments. One participant said, I see what you're doing. This is like controlled chaos. Well, uncertainty, confusion, and some chaos are parts of solving wicked problems that cannot be avoided. We found that good ideas can come from anyone at any time. As an example, we were presenting casualty figures as graphs that were not useful to the emergency medical people. Someone suggested that we show the figures in a spreadsheet so that the numbers and progression of casualties could be seen day by day. This worked. After failing to find a viable response system during workshops 1 and 2, and knowing that our next workshop would address a large-scale biological weapons attack, we knew that the teams had to be successful during workshop 3, or we were sunk. With the improved casualty spreadsheet, and intense effort, on the fourth day of the workshop, the emergency medical team formed an effective integrated casualty management system, and all the other pieces fell into place. This system held up for the next very large biological attack scenario. With the overall success of this program and the treaty verification program, we realized that we had demonstrated a general approach to solve very complex problems. We wanted to share our results and publish a peer review article in the Group Decision and Negotiation Journal. In researching the area, we found that we were solving, quote, wicked problems that had a mix of technical, economic, and social political factors snarled together. We asked ourselves, what makes our approach work? And came up with these answers. Total delegation of responsibility to the teams for bottom-up effort was needed. No bosses. We use problem facilitators to lead and enable others and avoid top-down direction. Maintaining an atmosphere of truth, compromise, goodwill, and learning was critical in motivating and allowing everyone to contribute. Learning is key as it's needed to understand the problem, but it also breaks down barriers and catalyzes creativity. We learned that our results were very similar to Dr. Peter Senji's work at MIT on corporate excellence. He published his results in a book titled Learning Organizations. We gained two more important insights into our approach. The wicked problem approach enables and taps the full human potential to solve wicked problems. In this way, it's the same as for Senji's learning organization in corporate settings. This inherent human potential is likely our greatest and most underutilized natural resource. I say underutilized because our normal way to deal with wicked problems are first ignore them or kick them down the road for others to deal with, or address the symptoms rather than the problem itself. Thus, we rarely solve wicked problems. Intrigued with the potential of the wicked problem approach and being then retired, I wanted to see if it was applicable to social political problems in addition to the two Army projects. Through the Acadia Senior College, I offered a course using the wicked problem approach to address development issues on Mount Desert Island. A co-facilitator and I organized and facilitated the course sessions. Participants developed a problem diagram, which was a precursor to what we use now. It had goals at the top, problem elements at the middle, and solution elements at the bottom. It answers three questions. Where are we trying to go? What are the barriers to getting there? And what do we need to do to overcome these barriers? Participants completed the effort, prepared a report, and were pleased with the outcome. They presented the final report to town officials. One participant suggested that we call our approach the wicked problem approach, and so it is named. Our resulting insight is that people can use the wicked problem approach to solve complex social political problems. With this encouragement, I presented our approach to the selectmen here in Penobscot, Maine, and suggested that we form teams of citizen volunteers to work on town issues. They endorsed the idea and encouraged us to form a People's Forum of Penobscot. They also provided a list of town issues that needed resolution. Door-to-door recruitment resulted in 20 volunteers. I provided two training sessions on the wicked problem approach to all of the participants. We started by dividing the volunteers into two teams to work on analysis of waste disposal options and on designing a municipal webpage. Problem facilitators came from the volunteers. This was the first time that I wasn't personally facilitating the problem-solving effort. Both teams were successful and prepared final reports, which they gave to the selectmen. The town used the waste disposal analysis to vote on which of two options to use for Penobscot's waste disposal. Their selection was fortunate as the rejected new facility went bankrupt and is not operated to date. Recommendations for the town webpage were accepted and the webpage was established. The People's Forum then took on two additional issues: waste recycling and analysis of school sustainment issues, the latter being a long-running controversy. Both projects were completed and reported and results implemented. The school sustainment issue proved to be very complex. The team first made a phase 1 analysis of the historical issues and current factors regarding the team's kindergarten through 8th grade school. With this knowledge, they completed a phase 2 analysis on options for school sustainment. This effort was instrumental in reaching broad agreement among town citizens and the selectmen that the town actually had a very good school, which needed more visibility. Acting on this finding, school enrollment has increased. Well, here were the lessons learned. I show the logo that one of the participants came up with for the People's Forum in Penobscot. Here's what we learned. Citizens can both participate and facilitate using the wicked problem approach to solve complex social-political problems. We learned that the approach is based on engineering, project management, and team leadership techniques. While successful, almost none of the town volunteers had such experience. Therefore, we needed to expand training to include project management and team leadership. We have, in fact, expanded the training to 6 sessions to include these techniques and better prepare problem facilitators. We asked for feedback from the participants and selectmen to gain their perspectives. Participants said they enjoyed the work, found it worthwhile experience, their input was valued, it was good for the community, and the town appreciated it. They felt satisfaction in helping and learning, and strong-willed people didn't dominate. An atmosphere of truth, compromise, and goodwill carried through. The selectmen wrote in the annual town report, "We are very grateful to the People's Forum for their extraordinary effort on this project," referring to school sustainment. Thus, we share a 30-year odyssey with the wicked problem approach. It has proven effective on many types of wicked problems and different types of participants. It is extremely robust because it relies on and taps our inherent human potential to solve complex problems. While it does not make solving wicked problems easy, it does make it possible. With these 30 years of experience, trials, and lessons learned, we are applying the wicked problem approach with confidence within the global solutions and outreach programs. To learn more about the wicked problem approach, I would refer you to the training sessions that are available here on the webpage. I'd also suggest that you please review our program proposals, summary, briefing, and details to see how we apply the approach to the problem of global warming. Thank you.